Welcome back. We're building a couple of bronze resonators. If you missed the first episode where we worked on some of this stuff, here's a quick recap. We deburred the edges of the tops and the backs. We got them all cleaned up and smoothed. We bent over the edge where the body gets soldered together. We rolled the lip that the sound well sits in. We made sound wells and we soldered the sound wells into the tops, and boom, that's where we're at. It's time to make some backs. If you're new around here, just know that making backs is difficult, like climbing Everest while holding your breath difficult. I've been practicing off camera a bunch, trying to get this figured out. All that practice has taught me that I've got two things that I need to deal with. One of the things, if you guys remember on one of the mild steel builds here, when you bead roll this depression in here, it leaves this hard edge that I don't like. I want that to be a nice smooth curve. I don't want that hard edge on there. So that's my first issue that I want to deal with. The second thing I need to deal with is what's the correct order of operations for doing this? Is it better to run the bead roll and make this depression first and then do the curvature of the back? Or is it better to do the curvature of the back and then run the bead roll through it? I did do the curvature of the back first, and then I ran it through the bead roller to make this depression. Stayed really flat and true. Everything's really good about that. This practice one went really, really well. What happens if I bead roll first and then I try to do the curvature of the back? And what happened was the top just went all crazy. So the order is bend over the sides, do the curvature of the back, then bead roll the outside edge. And that should give me the cleanest result that I can get. This is the bottom wheel of the bead roller that makes this depression that goes around here. I want to change this so that it doesn't have these two hard edges on it. I think what I'm going to do is I'm going to file down some skateboard wheels into a shape that I like. That will be the bottom, and it'll sort of match what the shape of the top wheel is. And that should give me a nice way to bead roll this edge without these two hard edges on it. This is the trial run of the skateboard wheel concept. It definitely gave this back a much, much smoother edge. Unfortunately, this is the back where the order of operations I learned was wrong. This is the one where I tried to bead roll first and then do the English wheel second, and that's just not the correct order. All right, in total, I think I made 4 practice backs out of that mild steel. So all that practice has made me sufficiently overconfident. I think we can move on to the bronze ones now. When I first started doing the English wheel and I was showing you guys my experiences with it, I got a bunch of great comments. One of the great comments I got was that you want to roll the metal through there in an asterisk type shape. So I think on this one what I want to do is I'm actually going to draw an asterisk on the back where I want these high spots to be. And having those lines on the back like that will just help me drive this thing through the English wheel a little bit better with a little more control, and I won't get so off. That should help me a bunch, so props to the comment section. Since one of these resonators is for Paul Welten, it only seems fitting to build it to some Paul Welten music. So here's a mother lode of all time lapses on making a back, and we'll enjoy Paul and Fritz doing their thing on resonators.
To the coast, where it goes, take me down. Bouncing on the torrent round, man's lover's hand. privacy.
Okay, I'm making some great progress on back number 1, but it's certainly not 100% done yet. It's really good though. I might stop on this one there for now and start on back number 2 and try and get that one up to this level of excellence, and then we'll go from there. Okay, I can't complain at all about that. I decided to just keep working on this back so that I would be super overconfident when I went to do Paul's. And yeah, I think I'm super overconfident now, and I'm gonna go and do Paul's. Seems to have gone really, really well. This thing's way smoother than the other one that I started out with. You can kind of see the mess that thing makes out of this sheet. Like, it really tears it up. It looks rough, but I promise you, that's pretty good. And that took me 15 minutes? That's nothing. The question I've been asking myself for the last 2 hours is the same question that guitar builders have been asking since the very first guitar. How smooth is smooth enough? So far the answer has been a little more, but now I think the answer is that's smooth enough. Unfortunately, it's so good I'm going to have to go and do this other one again. This one's really good, but it's not as good as that other one, so that means I got to go through and do this one again. Darn, that was a lot of work. Okay, this is a good visual. I just hit this one, the other one, real quick with 400 grit, so you could kind of see. Clearly, it's not anywhere near as smooth as that other one. I drew an asterisk everywhere I did the English wheel, and you can see I've got clear lines that stick out from that asterisk from where that English wheel ran. So this one, I think I used a little bit more pressure on this one than I did on Paul's, because I learned after this one that, like, man, you really don't need much pressure. You just need some patience and a lot of rolling. All right, I couldn't have Paul out in the wild running around saying he has the best 92 guitar back there ever was, so there you go. I got another one that's just as good as his. Okay, it's time to break into this second sheet of bronze that I bought. This is going to be used for the sides and the cover plates if we decide to make the cover plates out of bronze. Any little part that we need to make is going to come mostly from this sheet. Okay, if you guys are buying big sheets of metal online, kind of here's what to expect. So if you look here, this corner is just total junked. In fact, every single corner is totally junked. This corner is really bad. It's all bent up pretty good. And so is that corner. So all 4 corners of this one really took a beating. That's pretty par for the course. What's not usual and what's way worse about this one than other ones I've bought is that this edge is all beat up. So I've got a pretty good ripple there. I've got a really big bend over and ripple right here. That's pretty crazy. Yeah, look at that's pretty crazy. What's a bummer about that one is it's caused a ripple. The sheet's rippled all the way out to about, in fact, you can see it right there. It doesn't sit flat anymore. Normally it's not that bad. Usually the edges are pretty good and they're not beat up in the middle, but dang, this one really took a beating. And so it's really a bummer that this one doesn't have a clean edge on it to run the long strips, which means I've got to cut a clean edge, then cut the strip for the sides, which is, you know, a lot more work. Well, it looks like these guitars are going to get 2-piece sides. I was really hoping I could go diagonal across there and get 1-piece sides out of it. It looks like I could maybe get one. Maybe I'll do Paul's with 1-piece sides. Thing is, if I do that, though, it really screws up this sheet because I'm planning on sending this sheet to the laser cutter to cut out cover plates and other little parts that I need. Although, if we decide we don't want bronze cover plates, then maybe it doesn't matter. I decided to cut a section of the bronze sheet off and then run it through the bandsaw to make up the sides. I really didn't want to cut that sheet up at a diagonal angle and have a weird piece to give to the laser cutter. Okay, that should do it for cutting the sides. I got all 4 of them done and they all match perfectly. So we're good to go on those. Gonna bend them up and we're ready to solder these bodies together. All right, the next step for me is to bend the sides. Now, some of the other resonator builds I've seen, They tend to skip this step and they just wrap the sides around kind of a mold and clamp them in place and then solder them to the back. Now that seems to work fine because some of the major builders do it that way, what I can tell. But to me this seems worthwhile to bend the sides first, and that way I'm not soldering the sides to the back with a whole bunch of tension, right? When you just wrap it around the mold, it still has a ton of tension. It's trying to spring back away from that mold, and the solder holds it in place. Now the solder's plenty strong to hold these things in place. For me, I don't know, I'm content with bending the sides first. I'll probably experiment in the future with clamping instead of bending, but not today. Okay, I started with the hardest one to bend, and that one's done, and it fits great. It's a little bit long. You probably can't tell on the camera. It's probably hard to see. The rest of the other three should be a breeze because they're really nowhere near as complicated as this one. This one's got the 90 in it. It's got the cutaway, which is pretty difficult to bend correctly and get it to fit perfect. Yeah, that one went well. I'm just going to keep trucking along here and get the other three sides bent up, and then it's just a solder fest. Okay, the sides are all bent up now, and I'm prepping the sides and back for solder. I start by just roughing up the edge with some 220 grit sandpaper, and then I clean it with muriatic acid. The acid, it's sort of a double whammy. Like it degreases and cleans the metal really, really well, but it gives me the added bonus of etching the metal as well. I think when you combine that etching of the muriatic acid of the metal with the sanding that I do, I mean, that solder's really got something gnarly to bite into and hold really, really well. After sanding and the muriatic acid is complete, I hit it with flux, and at that point, it's ready to just clamp together and begin the soldering process. Okay, there's the inside of Paul's guitar with both sides on it now. Even though you can't see the inside of these much, especially on Paul's, he has those thin sound hole slots. So you're not going to see the inside of his like you would when you got F-holes or the grills or whatever. But I still think it's quite nice to have the inside of it just as good as you can get it. I think I'm ready to put the top in now. What I'm really excited about with this particular one is just how flat and everything is. Like, there's no tension in the body anywhere. Everything's flat. Nothing's pulling weird. It sits perfect. This is easily the highest quality body I've made so far. All right, I'm also very excited about the weight of this one. So far it's weighing in at just barely over 3 pounds. This is going to be the lightest body that I've made so far. Yeah, this whole plan is coming together fantastic. Okay, that's a pretty good wrap on the construction of Paul's body. The thing came out amazing. It's perfect. It just came out great. I'm really stoked on the quality of that. Once I get this thing all sanded and polished, that's just going to be beautiful. There's still some work to do to it, obviously, but I could go on and on all day about how beautiful that thing is going to be. I don't want to do that, though, because look what I got. I now have a CNC machine in here, and a big one. Okay, if you guys have been around this channel for a while, you'll probably know that getting these tops and the cover plates, it's not cheap to do that stuff. Now, Bruce up in Idaho has been incredibly kind to do this stuff, some of it for me. A lot of it I've paid for to do. It's just not cheap. All three of my kids are amazing at this stuff. I really don't know that much about it and how it works. They got this thing for me for Christmas. I didn't know it was coming. I wasn't planning for it. I mean, it was just on our dining room table underneath the blanket when we came down Christmas morning. It was incredible. This thing showed up from them. We spent a whole day just making space in here to fit it. Then we spent a whole day just setting this thing up and getting it configured. And then today I've been learning all about how to cam and things like that. Okay, here's 2 of the 3 that are responsible for the new wizardry. This one, so a sophomore in high school, and he uses these things at his robotics program. He's already been through the robotics program. He's on to college now, using much, much bigger ones of these. So got some experts on hand. They're going to walk us through a little bit of this. I think this is pretty self-explanatory, X, Y, and Z. It's just the 3 axis, right?
Yeah.
I don't know nothing about CNC yet, so I'm asking questions for me, not just you guys on the video. They've been teaching me how to cam today. And so this cover plate right here is my first cam that I've ever done. but maybe it was my second because the first one, was it a cam problem? I plunged the router through the plywood into the tabletop all the way to the collet on the router. That was my first go. I don't know if that was the cam problem that I made.
That was a setup problem.
That was a setup problem with the router. Camming.
Well,
camming is
telling your machine what to do from your computer. So you set up an operation which the machine will read and follow the commands so that it cuts where you want it to cut.
So this is one that we just cut, that cover plate that we cut there. And you can see this squiggly line on there, which I think is the toolpath, right?
Yeah.
So that's the path that the router followed while it was doing what it was doing. Now, you were telling me earlier, you don't need a big, powerful machine to run these CNCs, right?
Yeah, I've intentionally chosen the cheapest used computer I could find that was destined for an e-waste pile anyway. And I brought it in here to subject it to all of the sawdust and all the torture that it's going to be put through in this shop.
Okay, that makes me feel better.
Yeah.
And so we're running Linux on here. This is not a Windows computer, it's a Linux, right?
Yeah, it's running Debian 12.
And why do we want Linux instead of Windows?
So Windows isn't great with time-based processes. There's a lot of things that can slow it down or skew the
So if I translate that to English, this one just doesn't hiccup?
Yes.
And Windows does?
Exact.
We have, I think tomorrow we have a spindle coming, and it's, what is it, a 2 horsepower?
3 horsepower.
Oh, we have a 3 horsepower spindle motor coming, which runs on 220 volt. I don't know how much of a time saver it's going to be because it's really slow. Like when we were cutting this thing out, I mean, we stood there. What did that take? 28 minutes?
20
just to do the cover plate and wood.
You had to feed and wrap it on 50% though, so it would have only taken 12 minutes.
Could have been my fault that I was trying to be a little conservative.
Well, and once we get that higher horsepower spindle in, it's going to not struggle nearly as much. I mean, it's more than 3 times the horsepower of this thing, and so...
Took Ryder here a day to get this thing set up and working. Yeah. It took Austin a day to cut all the steel and weld up this table. Yeah, this has been a big group effort, and it took us a day to make space in here to put this thing. Mm-hmm. So yeah, we've all been working hard at it since Christmas.
And you're gonna have to keep working hard.
I'm gonna have to keep working hard.
Figure out how to do 3-dimensional CAD.
The 3-dimensional CAD is the easy part for me. I don't have a problem with that. The CAM piece of it, I've always understood what CAM is and does, but I've never known how to really do it. Yeah. So that's a new learning curve for me. But okay, that's good. We're off and running in the CNC world.
Endless possibilities.
Yep. Here we go. Oh, I can't wait to do fret slots on the CNC. No idea how you would do that, but I can't wait to do it. Because I'm tired of sawing fret slots. So that's going to be amazing. Oh, and I'll be able to do inlays on fretboards and things, like anything. It's going to be amazing.
Yeah, absolutely.
If I ever figure out how to do it. All right, day 2 of learning the CNC begins with unboxing my new spindle. I went with a 220 volt 3 horsepower spindle to avoid being limited on speed and power down the road. Unfortunately, it didn't come with any wire to connect it to the VFD speed controller, and it didn't come with a mount and a bunch of other stuff. It's pretty limited, really. So I couldn't really get it installed yet. I decided to get my daughter to teach me a bunch more stuff, and I even took notes so I could try and remember. We made some really nice neck templates for the 14 fret models. I carved a 14 in them so I'd know what they were for. If you're wondering why not just make a neck, well, it might be a minute before I'm good enough to cam a neck, so for now the accurate templates will help. I got the mock-up cover plate for Paul's guitar cutout, and I'm really happy with this design. Paul, please let me know what you think of this design. I think it looks great, but if you want to do something different or adjust it, let me know. And then we can figure out what kind of material we want to make it out of. This wood one's obviously just a pattern, so we can see if we like it or not. All right, I think that's a wrap on this episode. There's no telling what's coming next. I'm a bit overwhelmed still with all the new tech around here, trying to learn and figure all this out. Info is coming at me really fast. I'm trying to keep up. I'm feeling old. Anyway, yeah, I'm in the 21st century now. We'll see how that goes for me. All right, thanks for watching. Thanks for following along. Really appreciate it. See you guys later. So the Z offset is negative in relation to the top of the stock, but it's positive if you set the Z axis at the bottom. I don't know. Dang it.